Okay, so we're moving on to section 2.3, and 2.3 is called homogeneous equations with constant coefficients. So remember in section 2.2, we solved differential equations. We found the general solutions of these homogeneous linear differential equations. And remember, we used the characteristic equation in order to help us find the roots of the polynomial. Now remember, when you find the roots, right, or sometimes called zeros of a polynomial, they might be distinct, right? They might be not distinct. In other words, they might repeat. But we found real roots. So the question here in 2.4 or in 2.3, so let's see, in 2.3, let's see, maybe write some notes. So we're still obviously solving differential equations, right? That are obviously they're homogeneous, right? They could be non-homogeneous, which will work in 2.5, but if you can do homogeneous, you can definitely do non-homogeneous. They're definitely linear, right? And we're still working with higher order differential equations, right? We've done some quadratics, right, where the derivative is 2. We've done the derivative is 3, but it might be 4 or 5 or 6 or higher. So we still have this, but here the question is the roots. What if the roots of our characteristic equation are not real? Okay, that is, what if they're imaginary numbers? Is the solution of the same form? And so that's the question of this section. Again, very similar to 2.2. We're just going to be working with higher orders, so probably 3, 4, and 5. And again, our solutions might be distinct. They might be not distinct. They might be imaginary numbers. They still might be real numbers. They just might have, they might be irrational numbers. So that's kind of the big picture in this section. So I will stop here and I'll go ahead and start doing examples in the next video. But again, I just wanted to point out, right, we're still working, right, with linear, homogeneous, higher order differential equations. But now the roots might not always be real.